I want to share Bell Lab's perspective of where we see the manufacturing industry heading over the next decade and beyond through the adoption of 5G technologies. And this is going to be largely driven by the economic value that we see being created in the manufacturing industries as they begin to adopt 5G and begin to drive 5G use cases into their end-to-end operations. One of the primary drivers of the creation of economic value is productivity. I've shown here a plot of the GDP growth rates in the United States as a function of time. You see in the first half of last century, we had significant growth in our GDP growth rates. And this was largely driven by investments we had made in physical infrastructure, in our transportation networks, in our electric grids, in our road and highway infrastructure. These investments had broad benefits across all segments of the economy. In the latter half of last century, in the first decade of this one, we saw slower growth rates. This is the digital goods and networks age, a period where there were significant investments in digital networks, 1G, 2G, 3G, 4G, in PCs and computing. During that era, however, we saw relatively sluggish GDP growth rates. And one was that most of that investment was being done only in our digital industries. Those digital industries only comprise about 30% of our GDP. Whereas the lion's share, 70%, is locked in physical industries. Those physical industries have yet to experience the benefits of ICT investment. And we believe with 5G technologies, that is about to shift dramatically. So most of the growth of the next decade and beyond will be in industries. And the way value will be created is through what we call in Bell Labs a triangle of truth. So three simple dimensions that create economic value. First, safety, doing no harm, whether that be to people or property or the environment. Productivity, doing more with the same, taking infrastructure, robots, equipment, and using it, for example, to make other types of widgets. That's a productivity improvement. Efficiency, doing the same with less. This is whether that be raw materials or I'm now able to deliver my products with lower delays. All of those are efficiency benefits. And each of these dimensions have economic value to industrials. With the adoption of 5G technologies, industrials will now have new tools to drive safety, productivity, and efficiency improvements. Thanks to the low latency, high data rates, and high capacities of 5G, now we can connect massive numbers of sensors to a network. We can place sensors anywhere we want. These sensors may have extremely long battery lives and also extremely high data rates. So for example, we can place a tag on a device and with a device that has a battery life of 10 years, be able to track that device and read some properties about that device over time. We also now can put cameras anywhere in the operating environment and get high resolution images that can be used by a variety of different applications and processes to improve safety, productivity, and efficiency. Whether that's identifying people that are getting in harm's way, or it's looking for anomalies in the physical world that are can be fixed through operations changes. By connecting everything in the physical world with sensors and networking it, now we can pull all of that information into a network where it can now be used to optimize our processes. So augmented cognition and control, thanks to this digital fabric and these digital sensors, now we are able to build high fidelity models of the physical world in the digital domain. And using those digital models, we can optimize further safety, productivity, and efficiency. And using those changes that we calculate in the digital world, we can now command changes in the physical world through extreme robotic automation. We can send commands to autonomous machines and vehicles to further improve safety, productivity, and efficiency. We can dynamically control collaborative robots because now we have a common view of state for each of those robots, and we can tightly control them to drive safety, productivity, and efficiency improvements. We're able to orchestrate things end to end, not only on the factory floor, but throughout the entire supply chain. We're now going to be able to also augment humans with new superpowers. For example, we'll be able to have human operators remotely operate robots, drones, equipment, either for reasons of safety or for reasons of efficiency. One person sitting in one place can operate machines independent of location. Also, we'll be able to endow humans with digital personal protective equipment, equipment that monitors the health of our humans out in the field, and also is able to know where they are to keep them safe and keep them out of harm's way. All of these are new tools to drive safety and efficiency. We're using this in our own factory in Oulu, Finland, where we manufacture a variety of products, as you heard. We've seen with the use of 4.9G technology, the precursor to 5G, already a 30% year-on-year productivity improvement via automation. We've also decreased the amount of time our staff spends on the factory floor, keeping them out of harm's way, keeping them safe. We've also seen efficiency improvements by means of reduced lead times, thanks to the use of this agile robot infrastructure that we can command and reroute based on changes in our order mix and also changes in material. Now, we're going to be building networks quite differently with 5G than we had with 4G and the earlier Gs. And one of the main reasons is that 4G and other earlier generations of wireless technology were largely built for human communication, whether that's voice or video communication. And in those modes of communication, delays of 100 milliseconds or so are adequate enough for a good experience. However, as we move to industrials, we have now needs for extremely low latencies. And we need these extremely low latencies to be able to tightly coordinate robotic motion, to be able to increase throughput of manufacturing processes, and to have a real-time view of what's happening out in the physical world in the digital domain. We also need extreme reliability. We need fiber-like reliabilities in order to be able to safely monitor and control devices and also reconfigure factory floors dynamically. That means extremely low latency networks, extremely high reliability. So we've built all sorts of new functionality into 5G to be able to provide this. For example, we've now opened up more spectrum so that we can provide very dense, high capacity, high reliable service in a local area on a factory floor, as well as in the wide area. We've also introduced technology to provide beam steering and to coordinate transmissions among small cells to be able to better use the spectrum resource, which is quite limited. Also new ways to improve spectral efficiency through massive multiple input, multiple output antenna technologies. On the processing side, we've now also, because of these low latencies, the low latency between sensing, computing, and actuating, we now have to do this on the millisecond time scale. We can no longer afford to have data centers hundreds and hundreds of kilometers away from the devices. We now have to bring them very close to the device, and in many cases on premise with the devices for reasons of performance, low latency, and also privacy, data privacy. So we've built technologies to be able to orchestrate this cloud infrastructure end to end to provide both that low latency and also that high. So as we moved from 4G to 5G, we've added all sorts of new hooks to make the technology better. More spectrum, better ways of sending symbols over the air interface, more robust coding, being able to use multiple technologies simultaneously to be able to reliably send and receive control messages. And in the area of latency, most control messages for controlling robots and other devices in real time tend to be fairly short. So we've taken advantage of that to build ways to send these short messages very, very reliably at very low latencies, and in the process drop our latencies from, say, on the order of 30 milliseconds with LTE to a millisecond with 5G. And also now we're able to build fiber-like reliabilities on the factory floor and beyond, fit for industrial automation. And as a result, we'll see now more use of 5G. 4.9G is great, but now we're going to, with 5G, get even lower latencies that allow us to control things in real time, high resolution video for sensing, as well as a tight orchestration and control of robots and devices. And those are the primary tools that are going to be driving safety, productivity, and efficiency across all. And we're going to be, as a result, we're going to be building networks quite a bit differently than we had in the past. And one of the main changes is, instead of the centralized cloud and centralized processing, we're now going to be, and instead of having these centralized clouds doing all of the computation, now we envision a world where we're going to have these hyperlocal 5G networks that are specially built to provide the reliability, the data rates, and the low latencies that are needed for these different industrial manufacturing control processes, but also providing a way to link these hyperlocal networks with wide area 4 and 5G networks, so that as material and as machines leave a hyperlocal network and go out in the wide area, we now have a way to track those shipments and inform our systems so that they could further optimize safety, productivity, and efficiency. This wide area information is going to be extremely important when you're managing an end-to-end supply chain. I might have my local, hyperlocal network controlling my factory floor or my supply chain logistics warehouses, but now I have the ability to see the entire system end-to-end. I'm able to sense the entire state end-to-end, and now I'm able to re-optimize as things change. For example, if I have a supply chain disruption at one of my factory sites, now I'm able to reroute shipments en route to other parts of my supply chain to take that into account. And that's going to be a hugely powerful tool in driving safety, productivity, and efficiency. We also see now a move to a more software and as a service architecture. This is a way now to bring in the broad ecosystem of all the software companies and device companies that make say general purpose technologies, for example, to be able to locate things in time and space, but also now applications that are targeted at specific use cases and specific industries. This combination of this hyperlocal, highly reliable infrastructure, this wide area infrastructure, as well as a way of exposing this sensing, augmentation, and control to a broad ecosystem of applications and devices. This is going to be the thing that's really going to turn this GDP growth into hyperdrive, because now we've taken away a lot of the friction that had been in the market in the past, and also now we're unbundling a whole spectrum of new creativity to build these new use cases. We've done modeling in Bell Labs Consulting to look at what 5G automation, what kind of impact does it have on typical metrics that we use to track safety, productivity, and efficiency in manufacturing environments. The use of collaborative robots, huge benefits in productivity, for example. We're able now to use those robots, and because we can coordinate and move them, now we're able to make different types of widgets. I've got physical infrastructure that now I can reconfigure and control in real time in the digital domain. Huge productivity benefit, but also I can further optimize my as I'm making that same product over and over again, I can use that information to optimize and drive efficiency improvements. The use of video sensors will bring video information into a network where it can be used for a variety of purposes, to geofence people away from equipment, and if we see people cross that geofence, to shut that infrastructure down to keep people safe. Also to look for anomalies in the physical world that we can correct from the digital world. And this has benefits also in productivity and efficiency, as we're able to watch the manufacturing process, watch the widgets as they're being manufactured and further optimize. And the use of AGVs as well. We're able now, because we get people off the factory floor, reduce the number of accidents with involving humans, and we're also able now to reconfigure in real time as things change. So huge benefits to driving, safety, productivity, and efficiency. And the most exciting thing is the things we don't know about yet that will be invented and that are made possible through 5G technologies. Thank you.